Welcome to ARC307, where we'll talk about why modern cloud applications are so awesome, but also about whether using modern cloud applications makes it more difficult to take your application somewhere else if you ever should have to. So last year when I gave this talk, I was actually an enterprise strategist dabbling with serverless, and I kind of put my money where my mouth is, so now I'm actually part of the serverless team, so I took the elevator far down, but I still have a little bit of the strategy mindset, and I maintained the strategy outfit. So two things happened. A, we upgraded the session. We got an upgrade to 300 level, and obviously we got a room upgrade, so enjoy the show. Starting with modern cloud applications, like simple term, but as it goes, many people have different visions or different opinions about what makes a cloud application modern. So tiny preamble, little bit of definitions to do what we're talking about. The usual graph that you will see when folks talk about modernizing in modern applications looks like this. Unfortunately, this graph is wrong. And it's wrong for two reasons. The one is, A, containers and serverless are not two different things. Obviously, you can deploy container images in Lambda, and you can have Fargate ECS as a serverless runtime for your container. So that is already not correct. And second, it's not just about the runtime. When we talk about modern applications, are you putting this together in sort of a ClickOps, completely manual way? Probably I would not say that is all that modern. What if you have no observability? You don't use managed services? Well, probably also not giving you that label. If it's a giant monolith, it doesn't have APIs, it's not integrating with anything, it's written in COBOL, etc., right? That is not what we would call a modern cloud application. So we got to correct this picture a little bit and say the modern applications are those that best utilize the cloud. And my personal opinion to that is that's what I actually call cloud native, right? Things that use the cloud for what it was designed for and fully use the capabilities of the cloud. And the reason that is such a great thing to do is because you get all these nice benefits, right? You get more resilient and available, scalable applications. You get more transparency. You also get more cost transparency, right? You're not paying for this server where you're never quite sure what it's actually doing right now, but you're paying for function invocation. So if you have a business function in Lambda, you pay for that so you know what's going on in your business and the value that your code is generating, and you can map the cost against that. And of course, this also allows you to make changes more quickly, and you gain agility. And because this is fine-grained, you also have better observability, like where are your performance hotspots. It's not this like giant box that somehow doesn't run the way you would like it to, but you have fine-grained components that you can isolate, you can tune, so you get many, many nice advantages. So we are correcting this definition, forget that graph. We're really talking about applications that are fine-grained. Right, that gives us some nice abilities like failure isolation in case something should go wrong. It allows us independent scalability. These are loosely coupled, so we can make changes without dragging those changes throughout the entire system. And often they're also event-driven. That's a nice asynchronous style, gives us, again, some operational desirable aspects that we have, but it also makes it easy to extend and augment those kind of applications. So now everybody is gung-ho and say, oh, fantastic, sign me up, and perhaps I'm preaching the choir here anyhow, but then the question comes, oh, if I do this, is there a downside, right? Do I pay a price? And is that price being paid in me being locked in? Now, as an architect, I like those kind of questions, right? Some people would say, oh, don't worry, right? No, that's not true. You should worry. This is part of your design. You should think about all the scenarios, so this is a very legitimate question. But as an architect, I'm also trying to break down these kind of questions and not do this kind of fear-mongering and say, oh, this is always good and this is always bad. The world of architecture is a world of trade-offs, right? It's never that one thing is always right and another thing is always wrong. I often say architecture is not a Hollywood movie. It's not the battle sort of between good and evil. It's about making decisions and understanding the trade-offs. Now, the most powerful maneuver you can make there is twofold. The one thing is you can break the problem down into more dimensions, and the other one is you can broaden the scope of the solution space that you have available. Sounds maybe a tiny bit abstract, but that is really what I want to take you through, and then we map that to our favorite, unfavorite question about lock-in and switching cost. So the mindset that people come from when they have this question, oh, I would love to have everything in serverless, but can I not? They have a single dimensional view of the world. They clearly see that on the right-hand side, there's all the things they would like to have, right? And I already pitched it. It's modern, it's fine-grained, it's resilient, it's scalable. You use managed services, reduce toil, right? It's very clear there's many nice things on the right-hand side. But then there's this other arrow which says, ooh, but is there also red on the side? And unfortunately, this one-dimensional view is kind of sad because there is no happy place on this spectrum, right? Either you're on the right, you get these nice benefits, but you're like, oh, I'm losing on the other side, or I'm on the left and like, oh, I could have all these great things that I don't actually get. So there is no happy place here. This is somewhat depressing. So let's move quickly off that and let's see more dimensions. So let's break this down. This is not left or right. These are two independent dimensions. And we sort of think back about our sort of 5th grade geometry maybe. This is plotting the previous one-dimensional graph in a two-dimensional space, right? You just get a straight line. So this is exactly what we saw in the previous slide. But now we think in a broader universe, right? We have 2 dimensions, so we can have entirely different discussions. Like, does this really go up or does this curve flatten? Can I push this curve, right? I can really discuss about how fungible this is. And I can do something else quite magical, and that is the world isn't just 2 dimensions. Are there 3rd dimensions, maybe 4th dimensions if you really want to? No, we're not going there. We're going to stick with 3, right? But is there sort of a 3rd dimension that I can push to flatten that curve? And that's sort of a classic architect maneuver. Get out of this one-dimensional, black or white, the good and evil kind of thing into seeing the more dimensions, seeing the nuances, and seeing the trade-offs. So let's map that to our favorite, unfavorite topic of lock-in. Staying with the dimensions, lock-in also has many dimensions, right? Many people talk about, when they say lock-in, they think about vendor lock-in. Is the vendor locking me in? But that is just one of many, many dimensions. A product also has switching costs, because that's what we're really talking about, right? Nobody's going to jail here. Nobody gets locked up, right? It's about switching cost. It's a financial consideration. If I need to go from A to B, how much will it cost me in effort and time and money? And that breaks down across many dimensions. If I have a product, even if I build this product in-house myself, if I want to move off that, that isn't going to be free. There's a switching cost. Version upgrades cost money. So many of you might know, let's take Kubernetes, favorite open source project, version upgrades. We recently put a service in preview, and that is the extended support for EKS. And that's for, I won't make you raise the hand, that's for the folks who are on 1, 2, 3 Kubernetes, who are not upgrading. And why are you not upgrading? Because you're lazy, you don't want to? No, because that includes effort, you need to retest, you have other things to do, maybe the opportunity cost is high, so right now you're not making that version upgrade. And that's why we have extended support, because that's what customers requested. That is switching cost. It's switching cost between one service, between one version and another version. Skill set, right? What you know is always easiest to work with. So if you learn something new, you have a switching cost. So this is neither binary. As computer scientists, we always like to think in ones and zeros. Architecture is not ones and zeros. right? It's about shades of gray, about spectrum, it's about trade-off, and it's about seeing all these different dimensions. Last comment here, you see a funny one at the very bottom that you might not have expected, and that is mental lock-in. And that is actually a very interesting one, so I'll come back to that later. So mental note on the mental lock-in. So we stay with our dimension story. So a very nice model that we use to make the decisions is a two-dimensional model, and it's called the 2x2 matrix. It's a very simple model. We often make fun of it because it's so simple, but it is actually very effective. Because again, it breaks the problem down into two dimensions, and we can now intelligently think about how the dimensions relate to each other. So when we talk about switching costs, that is one dimension. But there is a second dimension, and that is the utility, the value you're getting out of what you're currently having. And again, that gives you a much more nuanced view on this topic. Now, this 2x2 matrix, I broke this down into 4 quadrants. The bottom left is relative simply. That's like low unique utility and low switching cost. That's like your USB charger or something, right? You lose one, you get the next one, right? It's all standardized, it's commodity, they're all the same, so there isn't much to talk about. Then there's 2 more quadrants, right, where it gets a little bit more interesting, right, where I don't get so much utility, but I'm restricted from switching. Maybe in the old days, sort of cell phone plans or kind of subscription long terms, they tended to use that. We also see that those models in the long term don't tend to survive so well because somebody will either come in and disrupt this, or in some cases the regulator or some supervisory panel will stop in and actually make that go away. So that doesn't work well for the customers, and it doesn't work very well for the providers either. Now the bottom right is interesting, right, where you get a unique utility, but it's easy to switch. There's not that many examples of it, but what I always say, like social networks, right? You can be on different social networks. Maybe you like one better than the other one, but if you want to switch, you just go to another one. The interesting one now is, of course, on the top right, and I call this the accepted lock-in, where you have a certain switching cost, and we talk about later how to manage that. So accepted here doesn't mean just like not care about it, but it means you're feeling you're getting a right trade-off because you're getting the unique utility, right? And that gives you, again, a much different view of like, I can drive down the switching cost, but I can also drive up the utility. So which dial can I turn? And you have a much more intelligent conversation. Adrian Cockcroft, good friend of mine, has a very nice way of explaining the top right quadrant. He tends to go to his talks and say, well, who here is worried about lock-in? And all the hands go up. And then he says, well, who is married? And then everybody sort of looks at the hand and like, oh, yeah, well. So there are cases where there is acceptable lock-in and the benefits outweigh the potential switching costs. So learn something for life today as well. Yeah, I should be cautious because, so I haven't locked myself in. So maybe I shouldn't be the one giving this advice. Summarizing this, right, this multidimensionality sounds a little bit abstract, but it's an extremely powerful maneuver, right? Rather than me versus you and in this versus that, you now have an intelligent discussion. You talk about switching costs. Costs are great because you can map the problem into financial terms, and you can see that there's different dimensions. So that's architect maneuver 1. Architect maneuver 2 is, as I said, it's sort of looking at the scope of solution and making sure you don't look for the solution in a tiny box, but you actually look for the solution across the entire spectrum. And anybody who works in software delivery or cloud operations or even traditional operations knows this kind of model. We always sort of believe there's the application developers, they sort of build stuff, the functionality, and then they deploy it, and then some infrastructure and operations team takes care of that. The technical term for the arrow is usually throw over the wall, right? That's what we do. And then there's sort of an arrow going back, which is called pass the blame, right? If something goes wrong, and we all know that this doesn't work terribly well. However, when we talk about switching, right, taking workloads from one place to another, that is an ility. These so-called ilities like the availability, maintainability, scalability, and sort of portability rhymes with that a little bit, right? So people think, aha, that should be something in the ility people. Now that has two problems. The first one is the model already doesn't work very well. I work on serverless, right? Where is the infrastructure? Well, that's us already. So you can see that model doesn't work terribly well. And also portability is not an infrastructure concern. So we have this fallacy that somehow the problems that the application developers create, we can solve at the infrastructure level, right? We can make it scale, we can make it reliable, we can make it secure, we can make it portable, sort of after the fact. That totally makes absolutely no sense, right? You should fix the problems where they originate, not in another layer. So what we see there with a lot of customers, I'm actually writing like a whole book about this kind of stuff, is that people say, that doesn't work this well, so they do something very different, and that is called platform. Internal developer platforms, platform engineering, many of these things where you say, there's still room for two teams. There's a team that deals with common elements, and there's teams on top that deal with individual functionality. That makes sense, but the interface is very different. Rather than asking the infrastructure team to like, oh, can I have another instance, or can you give me this resource? Rather now you have the lower level, or sort of drawn at the bottom here, I don't want to say lower level, right? But the blue box, let's say, they make the tools to make the orange box more productive. And that has a big change in mindset, and that also has a change in mindset for our topic of portability and switching cost. So the second important lesson here is solve the problems where they originate. Don't try to solve the problems in the other layer, because you're sort of depriving yourself of the biggest levers that you would actually have to solve that kind of problem. So let's talk about 5 different approaches. 2 of them which I believe don't work terribly well, and then 3 of them that actually work very nicely. So when this topic comes up first, and this is related to the blue and orange boxes, because often the topic comes out of a procurement, infrastructure, sort of traditional IT vendor selection, right? That's where, rightly so, the topic is brought up, but with a mindset of that perspective. And the tool that's most of the time used then is a service mapping, right? They say, oh, how different can these clouds really be, right? If we have a virtual machines, don't the other guys also have a virtual machine? There's a database, right? Surely they have a relational database, a message queue, even like a serverless function, etc., right? Roughly, if you zoom out far enough, doesn't this all look somewhat similar? Yes, but zooming that far out isn't the exercise here. So look at our data offerings, and I wasn't even able to update this from this year's keynotes, right? How many data services we have, right? You have Neptune, you have time series databases, you have document databases, right? You have relational databases, NoSQL databases, right? You have a whole portfolio. So what are the odds that another cloud has exactly that same portfolio? So there it gets already, sort of a little bit fuzzy. And my personal opinion is actually, it is good for the customer that the clouds are not carbon copies of each other. Because then essentially you wouldn't have any choice anymore. We have, I worked at 2 cloud providers. I know we have different philosophies, different product strategies, different implementations. And that is good because that gives you choice. But it also means that this is a much oversimplified view. This comes out of the old days of sort of box, I put one name in this box, I put another name into this box. That doesn't work very well in this world. Let's zoom in here a little bit, and let's pick one service. So I work on serverless integration, so one of my favorite services is EventBridge. Now, EventBridge is a very easily described service. You push events in, they get filtered, they get transformed, they get routed somewhere else. It's a very nice, highly scalable service, but it isn't sort of world's most complex to use service. It's very easily described what it does, and it does this one thing very well. Well, here are the characteristics of this service right from the documentation page. So what are the odds that another service, and I had to cut this off at the bottom because it wouldn't fit on the slide. What are the odds that the other service, the so-called equivalent service, would match exactly all those properties? And we haven't even talked about the fact that no service lives in isolation, right? This obviously has event sources from other Amazon services. It has event targets to other services. It has an integrated IAM, CloudWatch, CloudTrail, like all the other things underneath this service is integrated with. So the odds that this maps is actually very low. So you will find that some vendors use these maps. I don't think we do, at least I haven't been able to find one because it is not a useful exercise. You know, it sounds good, kind of, wouldn't it be so easy? But the short answer, it is not. So then we come to the second approach, and that's a bit more nuanced, but we still want to understand what works and what doesn't work. And that is based on sort of a fundamental idea of software engineering, so fundamental that Andrew Koenig gave this the name, the fundamental theorem of software engineering, and that is, well, we can pretty much solve everything by just adding one more layer of indirection. There's a corollary to this saying, and that is, accept the problems of having too many layers of indirection. So let's apply this, and this actually works pretty well. We have living proof that putting a layer of indirection actually helps us be able to mix and match technology. It affords us options, as I like to say. And we all know this example. So let's say you want the option to use different programming languages, right? Very natural. Now, always got to be careful not to stir a fight here between, the left and the right. I'm sure there's strong opinions, but let's say you have one application and you want to have the option, you want to have the flexibility that you can use any of these languages. Well, as architects, we know very well how this works. You put a common integration layer on top of this, right? Microservices, service mesh, whatever good names we have, common authentication schemes, common data formats, right? And that makes this problem go away. So we've done a very clever maneuver here. And the maneuver is that we harmonized one layer. We locked down some things. I call that giving up some options, right? You're giving up the option to maybe have different data formats and different authentication schemes and different transports, right? So you lock that down. But by locking that down, you gain diversity underneath. So we have living proof that this works. I come out of the financial services industry, so sometimes I say this is options trading, right? You're selling some options to acquire other options. And again, we know that this works. So this is classic abstraction layer, and this is good. So it would be very natural to take the same color and the same boxes and just put a few different labels and say, well, can't I just do this for the clouds, right? Can I just put this layer in, and I harmonize at this layer, and then life is good. Sounds good on paper, is not as good in reality. And the way I like to explain this is, we had a very large international conference here. I'm sure we have attendees from like 100 different countries. So shouldn't we speak like another common language, like Esperanto, right? Because that would be the common layer, right? Then we can all talk to each other. Yeah, and that would be really nice, but you know what? We all kind of speak English, and it kind of works. And I'm not a native speaker, but close enough, right? It all kind of good enough. So we don't need this extra layer. So the idea is sound, but getting it into broad usage is hard because we need to learn yet another thing. And drilling a little bit down, I talked about the nuances between the services and why services are not carbon copies of each other and why that is actually good. So let's say you have a service feature set A and B, and they have little gaps. So what do you need to do? Well, you have two choices basically, right? You either fill the gap, but that's going to be difficult to do. And I can honestly say I speak from experience here because in my early days, I built some serverless applications on AWS, and then I ported it to another cloud. Considering where I work, I should have probably done it the other way around, but I work here, so I started with AWS and I ported it over. I actually looked at what it takes. And the differences seem small, but they're fundamental. So our queues like SQS has a visibility timeout. It has a time to lift. The other queue did not have. So I had to put that in my code. I cannot add this to a service. DynamoDB has atomic appends. The other database didn't. So I can't go and make the other database have atomic appends. This is not easy to do. You cannot easily stick stuff into the existing services. And then to make the problem ever worse, right, we had reInvent, so all the announcements, you guys know last year we had over 3,300 significant features and services that we released. So this is a moving target. So you'll be doing this all the time. And the alternative is, of course, also not that great, because you say, okay, just chop it to the minimum, because then you're losing the utility. Remember the matrix, right? Now you're compromising on the utility axis, and you need to think very careful whether this trade-off is actually worth it. So I call this the grim wrapper. Like, it sounds easy, like I wrap these things and everything will be good, but in reality it is actually not. Coming to another reason why this doesn't work as well as it looks, and that is logical abstraction layers cannot abstract physical properties. Now, I talked to a friend of mine, they had a startup company, and they did the other way around. So they built serverless native, like the way you would build it, just straight out, and then they moved this to AWS. And what he said was very interesting. He said it took us 2 weeks, right? So it was actually quite quick. And he said all the problems we had, like the things we had to do, no abstraction layer would have helped us with, because the things they needed to do were exactly all these kind of things. Pricing models, right? What if one charges by invocation, the other one charges by runtime? If one has provision capacity, et cetera, right? The abstraction layer will not make that go away. Quotas, scalability, right? We have a lot of announcements in terms of faster scale-ups for Lambda. We announced SQS, FIFO groups, higher throughput. So there are scalability limits and targets. And if the other side doesn't do that, no abstraction layer will actually help you with that. Right? I talked about time to live and things like that, like sort of retry logic, error handling, right? They tend to be different. And then here's another sort of every vendor's favorite, unfavorite topic, service availability. If you map this to a service and it doesn't happen to be available in your region on the other side, there is very little that you can do. So we need to be a little bit smarter here. Logical layers are very good to abstract logical things, but they cannot abstract physical things, and we're building fine-grained distributed applications. They have a lot of physical characteristics. So I mentioned the options, right? So I hinted at this options trading. Wouldn't it be nice to have the option to move your workload? And it's mathematically proven that that option is valuable, right? That's why I say I never tell anybody not to worry about it. Options are always valuable. If the case comes that you need to do this, having that option has a positive net value. But like most things in the world, it also has a cost. And we just saw, right? You need to build some things your own. That takes effort. And I always remind people, you pay in opportunity cost. So if you pay your developers to do something, to build something or maintain a service by themselves because you don't use the managed service, you think about, oh, that developer cost me their day rate. No, the developer doesn't cost you the day rate. The developer costs you what else they could have been doing in that time. And if you have a good functioning business, that should be a decent multiple of the actual cost, because that's how you have a running business. Many, many years ago, I worked in Silicon Valley, and the number we used, that the opportunity cost, the value of an engineer hour, was more than $1,000 per hour. Now, it was a good business that we were in, but we were very productive. We had a platform team, right? So we could generate this value. So if you say, oh, the developer does this sort of a half a day, which really means like 2 days, right? That isn't $2,000. That is probably $20,000. So be very careful with your math here. You pay an opportunity cost. The other one that comes to haunt you is complexity. Right? Money, I don't want to say money is easy, but money, we have banks, right? We can borrow money, we can make money, we can have a loan, right? So ultimately you can get money. But complexity is much worse, because once you have too much complexity, getting complexity down is really, really hard. We are in a business of adding stuff generally as IT people. We always add more things. It's really hard to take something away. So be very careful there. The last one I already said, right? Lowering the bar means your utility goes down, so you're shifting in that matrix in the wrong direction. So as speakers and sort of IT folks, we have a little bit of a bragging contest. And part of that bragging contest is to have your own law, right? There's sort of Conway's law, right? So that is sort of the status, how we measure ourselves. The good news is you can make up your own laws. So I followed that advice and I made up Gregor's law, but it's actually not entirely, well, it's not made up at all, because the conclusion I came to by working with many customers, if you're never wanting to make a decision, if you're never wanting to put a stake in the ground, if you want all the options all the time on any platform, in any language, on any device, with any flexibility, at any scale, right, at any cost, like if you want any everything, you will drown in complexity. And as we said, that is the toughest pit to get yourself out of, right? Once you're in the complexity pit, undoing this is extremely difficult. So I comment a little bit on these options and financial story and why it's good to map things to money. Because money everybody understands, and money has a lot of theory behind it. Like people get Nobel Prizes in economics for dealing with these kind of things. So translating our technical problems into a basically money domain is a very powerful maneuver, and it can help us make much better trade-offs on this axis. So what are we trying to do here? We carry a liability. And as I said, that is not zero. Like there's a non-zero chance that you would have to switch, right? It might be 0.1% or 0.01, but nothing in life is ever 0%. And that will cost you something. So you carry a liability, very clear. Now you can try to reduce this liability, but I see too many folks trying to make this switching cost zero. And that makes little sense, because against this liability, you have the cost of reducing that liability. We said that's, the opportunity cost, the staff cost, the timeline that it takes you, right? If you spend 6 months building this thing and at the same time your competitors build a fantastic product, you never have anything to migrate, right? So there is cost against this. So the answer is not drive this down to the minimum. The answer is look at the sum of the investment now and the liability that you carry. And that, again, brings you into a much more balanced conversation. Now, there's sort of two common models which we can easily understand that. The one is options theory. People who trade in financial options, they call this the strike price and the price of the option. And actually, these people know very well that trying to drive the strike price, so that's the price you pay when you utilize the option, like when you need to move, driving that to zero is actually not a useful exercise, because an option with a strike price 0 is actually a purchase. It's no longer an option. You already paid for the whole thing. It's no longer optional. You're not gaining anything, right? You have a low probability, but you assume it's 100% you already paid. That is not a smart investment. So using these metaphors, right, translating this into this world gives you some very clear insights. Talk to any financial person, say, oh, I want to have an option with strike price 0. And they're like, well, no, that makes no sense. So we can learn from that. The other thing we learn here is that it's a little bit like insurance, right? Insurance is also a liability we carry. Right? Health insurance, right? I carry a liability that, if I go off the stage, I could hurt myself and that will cost me some money, right? I carry that liability and it's not 0. So I have insurance against this. But as many of you guys have experienced, right? Go to your car insurance vendor and say, I want a 0 deductible, right? I don't want to have anything to do with this, right? You pay for everything. They say, great, can be done. Here's your premium. And then you say, oh, never mind, right? Because that will be really expensive. The upfront cost is going to shoot up. So this is no different. This is like buying insurance. And that's why don't be naive, right? Don't say, oh, don't worry, lucky, go happy. No, absolutely not. But also don't be over-insured. Look at the middle price or the middle range. There's another important aspect here, and we're diving a little bit. This is not a lecture on financial management, so we'll come out very soon. But there's one more important aspect. Today's dollars are more expensive than future dollars, right? And now we have inflation again and interest rates, right? So we know this. There's a discount rate. If I can pay later, that's why we have all these things, right? Pay 90 days, pay in 1 year, because the money in the future is cheaper than the money it is right now. And that also has an impact on this decision model. This upfront investment, the yellow-orange line, that is today's money. You're doing that right now. Versus the purplish line, my liability, that might be 1 year out, or more likely 2, 3, 4, 5 years out. So that switching cost is actually less in today's dollars. And organizations who do financial management, they know this very well, and they have an annual rate of return. They have sort of a fictitious interest rate that tells them how much cheaper the future money is than actually today's money. And the organization where that number is highest are the fastest moving organizations, right? They live in the here and now, and spending $1 million now is really, really expensive for them, and you're getting $1 million back in 5 years is probably worth less. And this explains why those organizations rarely have a big sort of cross multi-cloud platform initiative, because the cost of doing that right now to them would be very, very high. It could be the cost of the whole business. You know, as I said, if you spend 6 months building this, your competitor launches a product, you have nothing anymore to migrate. So apologies for the deep dive in sort of financials and options, but it really sharpens your thinking as an architect, how you find the right balance and understanding why fast-moving organizations rarely ever do this. And this mimics my experience. Most of the time, the requests come from large organizations, right? They're slower moving, so the discount rate, that interest rate, arguably is lower. So for them, maybe the balance comes out slightly different, but here's the catch. They all say, we're doing this cloud thing and the cloud native and the modern apps because we want to be like these other applications, or like these other organizations. We want to be fast-moving and agile and digital. But yet they make decisions like the old organization. And that is not a smart thing to do. If you want to be like the other companies, think like the other companies. Assume your internal discount rate is high. Assume today's dollars are very expensive. Assume your opportunity cost is really high, because that's how these organizations work. So if you want to be like those organizations, make decisions like those organizations. So there's a common counterexample that is given where this seemed to have worked very nicely, and that is SQL, right? Almost all our databases support SQL, right? And largely that works, but again, there is a nuance. It helps to sort of read up on history a little bit. SQL was a productivity tool, not a portability tool. It was built by one company for a special purpose to make it easier and faster and more productive to work with relational databases. And then another vendor said, oh, this is actually pretty nifty. I am going to take that. But that was not the trigger. It was a productivity tool to make it easier for developers to work with these still very new relational systems, right, with relational algebra. It has a very strong theoretical foundation. This isn't just sort of somebody made up a language, right? The relational algebra underneath is very rigid. And still, SQL doesn't seem like the most complex language. They even stopped publishing it in a single document because it got too large. So doing this, even for a relatively simple model, turns out to be quite complex. And as everybody knows, tuning on different database products is different. It's the physical stuff. SQL abstracts the logical part, the physical things you still need to do. So yeah, SQL is great, but remember, that is not an example of achieving portability. It was really a good example of achieving productivity, because we wouldn't really want to be working without it. So that is my big pitch here, that productivity has to come before portability. If you're not productive and somebody else is, the question of portability will actually never ask itself, and that is probably not a good thing, because that means your business is not in good shape. And that's a little bit my sort of tiny pet peeve with a lot of open source projects. I'm a huge fan of open source, right? My open source projects aren't like that grandiose, but I always try to share whatever I have. But I feel that the open source projects selling themselves slightly undervalued by always leading with a portability argument. Like, you have so much more to say. You have the community, the openness, you can extend, you can review, right? You can be more productive. There's so many more great things that open source projects do that I feel if you just focus on this one aspect, you're kind of selling yourself undervalue. So I tell people this straight out. Well, why don't you say developers are more productive doing this, right? And also maybe you get portability. I think that is actually a better pitch, or you can collaborate, you can enhance, right? Those are the essential factors of open source, and then the portability may become sort of as a side benefit, and that is totally okay. So I promise I have 5 approaches here. So we're done with the bad news. So done with that. Now comes the good news, right? What actually does work? Well, here's an obvious one. We just talked about open source, and what a big fan of open source I am. And indeed, managed open source works very well. It makes you very productive. These are nice services. It's easier to find the skill set. We do all the operations for you. And if you need to do that somewhere else, some of the physical details aside, by and large, you get a very similar thing. Yeah, and it's unsurprising that we have actually quite an extensive list of managed open source services. This is not even complete. It wouldn't fit on the slide, right? But you have either true open source. I'm in the event streaming, so we have streaming, Kafka streaming services. We have MQ, RabbitMQ, ActiveMQ. We have databases. We have Cassandra compatible databases. You pick out of almost any area here. Kubernetes sort of goes without saying, right? So out of almost every area, we have managed open source services. And these are great. Use them, right? We make more of them all the time. And this is a nice way to get your utility, but also keep your switching costs in check. So that is in the nice green quadrant here. So very obvious, but that's something we should do. So the nice thing here is you have a specific service. They do what they do very well. You don't need to deal with the toil, like the heavy lifting that we do for you. But at the same time, you keep the switching costs in check. So that's a great thing to do wherever you can, right? I highly recommend. But not always is there an open source service. I work on serverless, right? I work on Lambda, EventBridge, step functions, right? Let's be honest, those are not open source services. So what do we do in that case? Remember the dimensions. I sort of hinted that like Z dimension, that third dimension. So let's talk about that dimension. Remember, this was the picture we had where, what does this curve look like? But the magical maneuver was sort of, can I push this into the third dimension? And does that meaningfully reduce my switching costs? And the answer is yes. And that dimension is velocity. And that is your own velocity. So that is another maneuver. Remember I talked about don't make the solution box too small. All right? So many people think this switching cost topic, that is a service selection and a vendor kind of management topic, right? They think that's us, right? But that is looking at only one half, right? The other half of this is how are you working? And that has nothing to do with sort of passing the buck from one side to the other. It's just look at the problem from the whole scope. There's two parties here, and two parties have dials they can use to manage the switching cost. And the biggest dial, a very powerful dial that you have is velocity. And the great example I always give, like many years ago, there was sort of some JDK, I think it was 1.6 or something, it went out of support, it had some exploits, everybody wanted to get off JDK 1.6. Now compare two organizations, right? I worked in one organization, I shouldn't mention the name, right, where this was a giant project. Right, it was millions of dollars on plans, and we can migrate, and we do this, and it was like, it was painful to no end. And now imagine a startup company, highly automated tests, CI/CD. They probably did it like last weekend, and they don't even know, right? So the switching cost is like many orders of magnitude different, even though they use the same product. And it wasn't the product that did anything bad, like JDK is fantastic, right? It was just the way they worked. They had a different velocity. So that is a huge dial you can turn, and don't ignore that dial. That is part of your solution space. How do we do this? Well, there's many other talks about it, right? It's a well-known topic, but how do you increase your velocity? Well, reduce friction, get higher levels of automation, automated build, automated tests, automated deploys, right? Well-known kind of things. Don't have feature branches that live for like a year and a half, right? That is not velocity. Push things into trunk, reduce your inventory. And the other thing is, well, it's sort of a little bit of smart advice. Don't build things that don't add value. Now, the retort is, of course, well, if I knew that they had no value, why would I build them? Now, there's a better answer to that is make smaller iterations. Build small pieces, see how they go. If they work well, do more of that. If they don't go well, do less of that, right? That is the real answer there. And all these are like totally well-known approaches, right? Reducing the friction, that is DevOps, we all do. Right? Reducing inventory, that is lean, comes out of manufacturing, flow optimization, right? Reducing inventory, we all know how that works. And of course, building things for maximum value, that is about agility. If you find out that one thing doesn't actually provide value, you stop working on this and you do something else. So the important message here is that the solution space is bigger. It's not just about service selection. It is also about your own velocity, because that can have an order of magnitude impact on the switching cost. Right? I gave the example of the folks who did this in 2 weeks. They could only do this in 2 weeks because they ran a very lean ship. They were very sophisticated software developers. They had automation, and that's why it took 2 weeks. They had high velocity. So it also depends on how you work. So we can get at this problem from both sides. Last one I have, so I promised three good news. And remember, I hinted sort of this mental lock-in. I said, make a note on mental lock-in, so we come to mental lock-in. So we go back to our favorite service here. Exactly, I have Event Bridge, right? Let's say I put this down on my architecture diagram. I'm using Event Bridge. Great, you should be using Event Bridge. Fantastic service. I work there. I love it. What did you really try to achieve? Right? This is not expressing the intent. This is the solution you chose. This is the service you chose to do something. But it's very hard for me to reverse engineer what it was that you wanted to do. I probably have to look at all your code and sort of guess. That is lost. And even though, as I said, this is a very well-defined self-contained service, you can do many different things with this. You can filter out messages. You can route messages based on the content to different places, right? You have these expressions and the targets, right? The filters and the targets. So different messages can go different places. You can transform messages, change what the data formats are and the fields are called, and you can send messages to multiple places. So I use my 20-year-old pattern language here to express this, and I'm always kind of happy that this still applies, but the right-hand side expresses the intent. That's what you are looking to do. The left-hand side is the ultimate decision. That's the service selection that you make. Now, you might wonder what that has to do with switching cost. Actually, quite a lot. Because if you only think in the icons, right? And I work for AWS. We love our icons. We love our services. They're all fantastic. But here's the message, right? If you only think in those icons, you've become mentally locked in. You think like us. And that makes it harder to think like another platform, right? Totally transparent, right? So basically, use the services for what they do well, and there's many things that they do well, but don't replace your own thinking with a service selection. Maintain that intent, your decisions, your trade-offs, the things you were trying to achieve. Maintain those and don't replace those with the selection. I think that's, in my view, is one of the biggest sort of architect fallacies or sort of that people fall into. They believe their architecture is the service selection. And sometimes maybe we're even a little bit guilty of doing that. It's like, show me your architecture. You get the diagram with the service icons. It's like, yeah, that's sort of the implementation, but there must have been a lot more that was going on in your head when you designed and architected this application. So don't lose that, because maintaining that also reduces your switching costs, because you don't need to reverse engineer this out of a service. Because let's say on the other side, there might be different services for filtering versus recipient list. The other event router might do filtering and transformation, but it might not do recipient list. So if you lost that knowledge, you don't even know where to go. So don't lose that. To show how important this intermediate step is, this like thinking about your solution, understanding the intent and expressing the intent, I have one more example. And again, I'll use sort of the old stuff from 20 years ago. Simple pattern, scatter gather, right? You have something to do that involves multiple parties and you want the single result. We had an insurance example earlier. It's like insurance broker, right? I need my car insured, everybody please give me a quote. And then at the end, I want to have an aggregate view of all the different responses. So classic pattern out of the enterprise integration patterns. So as an architect, I'm convinced that architecture is the sequence of meaningful decisions that you make. It's not like some random picture, but it's the decisions that you make. So let's talk decisions. So here's a decision, right? First design decision is, do we know the number of recipients? Does this change all the time? Do we know, do we not know? Makes a huge difference. Right? If they come and go all the time, you will build a different system. And mapping this back to services, right? Event Bridge might not be the right approach, probably much more in SNS land. But the driver was that the recipients come and go more frequently and you don't know how many they are. Makes a huge difference. So maintain that decision. Are they required to respond? Can they abstain? Because if I know the number but they can abstain, I still don't know the number of messages that comes back. Aggregating is a very interesting and much more complex task than it seems. How do I know that I'm done? Do I have all the messages? Well, that works only if you know how many it is and they cannot abstain, right? If I don't know the number of messages, do I time out? Do I wait for a certain number of messages, like 3 is good enough? Do I have a sort of incremental timeout or absolute timeout? Do I qualify a message as good? Like if I get a number that I like, do I stop listening? Many, many, many different strategies, right? And this is architecture thinking. So when you know you're done, you still need to produce the result. What do? Do you collect all the quotes like an insurance aggregator would do? Or do you just want the best number or the sum or the average or the max and min, right? There's many, many things you could do. So don't skip this step, because there's two very, very important lessons. Is none of these you find in the icon, right? This is we talk so much about generative AI and artificial intelligence. This is your human intelligence, right? This is you as an architect, right, making these decisions. And none of this you will find in the icon. And you can have this discussion with a business user. Try going there and say, hey, I need to configure this event bridge JSON path kind of setting. Which one do you want? The business user is going to go like, well, good luck. This discussion you can have with a much broader audience. They will understand this, right? Do they need to respond or not, right? They say, yeah, yes or no, right? So you have a much more insightful discussion, and you can maintain this intent. And then once you're done with this, then you map to the service. And that way, you're not mentally locked in, you maintained your intent, and if you ever need to do this somewhere else, you have this as a starting point, not just a nice, colorful icon. So really word of caution here, right? If you jump to the services so quickly, if you consider architecture just an exercise of service selection, you might be missing the most important part. And acknowledging this part, right, and respecting that part also helps reduce your switching costs, because you have a better starting point and you're not mentally locked in. You can express what you're doing in architecture, design, and pattern terms, not just in service terms, because they will be very different on the other side. So where did this lead us? So we talked about a lot of things. We talked about dimensionality in multiple dimensions, and lock-in, and marriages, and options theory, and strike prices, and SQL. So let's kind of land back down here. Well, I warned we increased this to 300 levels. But let's come back down. Where are we? So the powerful maneuver that we did is we didn't shy away from the topic, right? It's so easy to say, oh, don't worry. No, you should worry. But you shouldn't worry in terms of like, oh, my fear of lock-in. You should think about this kind of problem, and you should reframe that problem. And you reframe this by understanding nobody gets locked up. It's about cost. This is about money. It's about liabilities. It's about the likelihood that something takes place, and that's how we really sharpened our thinking about it. Then these dimensions really helped us, right? The utility versus the cost dimension, the different dimensions of the switching cost, right? That was a very powerful maneuver. And then this options theory really helped us to say, hey, this is not about making the strike price be zero. This is about minimizing the total cost and understanding that today's investments are more expensive than future payoffs. So that was the powerful architect maneuver that got us from like fear-mongering, or in the other extreme, ignorance, right? It got us out of the two extremes into a sensible conversation. So what did we learn? We learned that sort of the obvious approaches don't work that well. They might be obvious thing to do. You map one to the other, and if you need to move there, hey, you have the same thing kind of anyhow. We understood that doesn't work very well, and that's why we don't publish those kind of mappings. And we also learned that this abstraction layer works well in some cases, but it doesn't work very well for distributed systems that have a lot of physical aspects plus cost aspect, right? Werner this morning talked a lot about cost being one of the illities, right? It's one of the non-functional aspects, so that doesn't work with any abstraction layer. So then came the good news, right? Things that we should be doing because we should think about this. The first one was managed open source, right? That is a very obvious one. The second one was your velocity, right? Think about all sides of this problem and solution space. So you can increase your velocity, and that dramatically reduces your switching cost. And the last one was, don't get mentally locked in. Maintain this design intent, be very clear about the decisions you make, and when you're clear about that, then the icon comes. Now you might say, hold on, dude, you now spend 45 or almost 50 minutes basically telling me I should do good software development, right? I should have high velocity, I should use patterns, I should good architecture, and the short answer is you're essentially right? If you have development discipline, if you express your design intent in patterns, if you have high velocity, if you have good levels of automation, the switching cost isn't going to be your biggest problem. Right? So in a way, yes, the essence of all this options theory and all that kind of stuff was, yes, run a lean, good software delivery shop, and that is, if the time would ever come, you are already well prepared. Use managed open source as a bonus, but in the end, the switching cost isn't going to be your biggest problem. Capturing the opportunity in the market and having the right velocity, that is really going to be the problem that you should focus on. So I hope I was able to inspire you a little bit by tackling a topic that most vendors don't really like to talk about. I'm always a little bit proud that I get to have the only talk with the words lock-in in the title, but hopefully we can see that it's a very nuanced topic and we can use our architecture brains to actually have an intelligent discussion about this. I sometimes write books. It helps me straighten out my thoughts, and I have a blog. So if you like this kind of way of thinking, I also always invite you to have a look at those kind of things. So with that, thank you very much.